Hi everyone, in today's lesson we're looking at trigonometric identities. And a trigonometric identity is a trigonometric equation that is true for all values except those for which the expressions on either side of the equal sign are undefined. The following three equations are known as reciprocal identities. So we have the cosecant, the secant, and the tangent. So the cosecant is equal to 1 over the sine. The secant is equal to 1 over the cosine, and the tangent is equal to 1 over the cotangent. The tangent identity is tangent of theta. That's equal to the sine of theta over the cosine of theta. The cotangent identity is the cosine of theta over the sine of theta. And then last but not least, we have the three Pythagorean identities, and the first one is the one that we're really going to look at today. Sine squared plus cosine squared equals 1. Now this one's used pretty heavily, and it is included in the IB formula booklet. But I would just encourage you to memorize it because it does sort of pop up a lot. And the way I like to encourage students to memorize it is I do like a little cheer. Sine squared plus cosine squared, we are 1. Sine squared plus cosine squared, we are 1. Hopefully you'll remember that. All right, and there's two more. 1 plus the tangent squared of theta equals secant squared. The other one is 1 plus cotangent squared theta equals cosecant squared theta. But really, the most important one that we're going to look at is, again, our friend sine squared plus cosine squared equals 1. So we're going to look at some examples. We're going to use the Pythagorean identity, sine squared plus cosine squared equals 1, to evaluate for sine, cosine, and tangent. So we're given some information. We're told that the cosine of theta is negative 2/3, and the tangent of theta is less than 0. We have to find the sine and the tangent using the Pythagorean identity, sine squared plus cosine squared equals 1. So I've laid out what the steps are. The first thing that we need to do is we need to identify the quadrant using our knowledge of the unit circle. And if you remember, when we talk about the unit circle, I have an acronym that I use to help you remember what the values of the signs are for sine, cosine, and tangent. So the acronym was all students take class, right? So that means that everything is positive in the first quadrant, sine, cosine, and tangent. Only sine is positive in the second quadrant, so cosine and tangent are negative. In the third quadrant, only the tangent is positive and sine and cosine are negative. And in the fourth quadrant, only cosine is positive and sine and tangent are negative. And we're being told that the cosine is negative and the tangent is negative. So we're going to be in a quadrant where only the sine is positive. So we're going to be working in the second quadrant. Step number 2 says substitute the given values into the Pythagorean identity. Let's write out our friend sine squared plus cosine squared. We are 1. And we'll fill it in for the information that we have. So we have cosine, so we don't know sine. So that means we have sine squared theta. If we square this, we're going to end up with 4/9 equals 1. So we'll have sine squared theta equals 1 minus 4/9, which is 5/9. We're going to take the square root of both sides. So we know that the sine of theta is equal to positive root 5 over 3. The square root of 9 is just 3. And we know it has to be positive because we've identified that we're working in the second quadrant because cosine and tangent are negative. So we found our first solution, root 5 over 3. Let's fill that in. And the last part is solve for the tangent using the tangent identity. Tangent is sine over cosine. So the tangent of theta is equal to the sine of theta, which is root 5 over 3, all divided by the cosine of theta, which is negative 2 over 3. Whenever we're dividing by a fraction, we're going to multiply by the reciprocal. So the tangent of theta is going to be equal to root 5 over 3 times the reciprocal of the denominator. The 3's will cancel, and we're left with negative root 5 over 2. Right, so that is letter A. There are 2 more practice problems in these notes. I would try them both on your own before you watch me do them. Letter B, if the sine of theta is equal to a half and theta is between 0 and pi over 2, find the value of cosine and tangent using our friend, the Pythagorean identity, sine squared plus cosine squared equals 1. All right, so let's identify the quadrant that we're working in. They're telling us that theta is between 0 and pi over 2. So on the unit circle, we start at 0, we go to pi over 2, we go to pi, we go to 3 pi over 2. In the first quadrant, everything is positive. In the second quadrant, only sine is positive. In the third quadrant, only the tangent is positive. And in the fourth quadrant, only the cosine is positive. And so we know that we've been told that we're between 0 and pi over 2. So we know that we're going to be working in the first quadrant. Now in step 2, we're going to substitute the given values into our Pythagorean identity, and we're going to solve for either sine or cosine. So first we're going to write out the Pythagorean identity, sine squared plus cosine squared equals 1. We know that sine is a half, so we're substituting a half in. So 1/2 squared plus cosine squared equals 1. 1/2 squared is 1/4. Cosine squared theta is going to equal 1 minus a fourth, which is going to give us 3/4. We're going to take the square root of both sides. So we're going to get the cosine of theta is equal to root 3 over 2. And we know it has to be positive. We said that we're working in the first quadrant, and everything is positive in the first quadrant. Now we have our cosine, we have our sine. We're going to solve for the tangent. The tangent of theta is equal to the sine of theta over the cosine of theta. In this example, the sine of theta is a half, and the cosine of theta is root 3 over 2. All right, so the tangent of theta is equal to 1/2 times the reciprocal of the denominator. The 2's will cancel. And so the tangent of theta is equal to 1 over root 3. Now, I certainly don't mind if you leave the denominator with a radical in it, but if it bothers you because it isn't considered simplified, you can rationalize the denominator. And that would mean we would multiply by root 3 over root 3, and that would give us root 3 over 3. So either example I would take, but sometimes when you look up answers, they'll always give it to you in the rationalized form, but I would take either one of those. All right, and the last one, we're told that the cosine of theta is 8 over 17. We're working between, theta is between 3 pi over 2 and 2 pi, and we're going to find the values of sine and tangent. All right, so we want to identify the quadrant. On the unit circle, again, we start at 0, we go to pi over 2, to pi, and then to 3 pi over 2. In the first quadrant, everything is positive. In the second quadrant, only sine is positive. In the third quadrant, only tangent is positive. And in the fourth quadrant, only cosine is positive. We're being told that we're between 3 pi over 2 and 2 pi. So we're going to be working in the fourth quadrant. Now we're going to substitute our given values into the Pythagorean identity and solve for either sine or cosine. We were given cosine, so we're going to be solving for sine. So we have sine squared theta plus 64 over 289 equals 1. So sine squared theta is equal to 1 minus 64 over 289. That gives us 225 over 289. We're going to take the square root of both sides, and we're going to get the sine of theta is equal to the square root of 225 is 15. The square root of 289 is 17. And be careful now, the sign in the fourth quadrant is going to be negative. So we want to make sure that this guy is negative. So the sine of theta is negative 15 over 17. Okay, last part, find the tangent. The tangent of theta is equal to the sine of theta over the cosine of theta. So in this example, the tangent of theta is equal to negative 15 over 17, all divided by the cosine, which we were told is 8 over 17. So the tangent of theta is equal to negative 15 over 17 times the reciprocal of the denominator. The 17s will cancel, so we're left with negative 15 over 8. Okay, everyone, that's all I have for this lesson. Hope you enjoyed it. Have a great day.